So this lesson is on solving rational equations. We've worked with solving equations in every single chapter of this textbook, every single unit that we've hit. Last unit, with the logs, we worked on solving the rational equations, and then we had to check for extraneous solutions. Same thing's going to apply for this unit, so please remember to check your solutions every time. I will take off points if I don't see the check. So let's first look at this example. We have 4 over x plus 5 over 2 equals negative 11 over x. I'm going to show you two different ways to do it. We'll start with what we would probably assume to do. So 4 over x plus 5 over 2, naturally, we'd want to make that as one fraction. So I would first look for the least common denominator, and looking at the x and the 2, we need to take each one of these and put them together, and our least common denominator is 2x. So we have 2x, that means we're going to have to multiply this fraction by 2 over 2, and this fraction by x over x. And 2 times 4 is 8 over 2x plus 5x over 2x equals negative 11 over x. Well, if we add those together, we have 8 plus 5x over 2x equals negative 11 over x. So all I did was I made the left side one fraction, and then I have both of these set equal to each other. Well, when we have two fractions set equal to each other, hopefully what you're thinking is I can cross multiply. I can take my numerator of one and multiply it with the denominator of another, and then set that equal to multiplying the other numerator by the other denominator. So we have x times 8 plus 5x equals negative 11 times 2x. That's going to give us 8x plus 5x squared equals negative 22x. So I'm going to add 22x to get 0. 0 equals 5x squared plus 30x. And then we factor and set each factor equal to 0 using the zero product property. So 0 equals, take out a common GCF of 5x, and we're left with x plus 6. So 5x is going to equal 0. So x equals 0, and x plus 6, oops, sorry that I've run out of space, is going to equal 0, so x equals negative 6. But we have to check our solutions. If we check, we're going to see that if I put in 0, 4 over 0 plus 5 over 2 equals negative 11 over 0. Can I divide by 0? No way. So 0 is not going to be a solution. But if I do 4 over negative 6 plus 5 over 2 equals negative 11 over 6, that's going to give us 5 halves. That's the same thing as negative 15 6. So we're going to have negative 4 plus 15 over 6. And 15 minus 4 is 11. Oop, I see my mistake. It's negative 11 over negative 6, which is positive 11. And there we have this equals 11/6. So our solution is going to be x equals negative 6. So you can get it to be one fraction, like we got here, and then cross multiply. But there's another way to solve this. Let's look at the same problem again. We have 4 over x plus 5 over 2 equals negative 11 over x. If we look at the least common denominator of every single denominator here on both sides of the equation, we still see that the least common denominator is going to be 2x. So to solve a rational equation, you're going to multiply each term on both sides of the equation by the LCD of the terms. So let me write that. Multiply. This is another way to do this, and it will be easier. Multiply each term on both sides of the equation by the LCD of the terms. Now remember, it's talking about the terms of every fraction, every rational expression, not just on one side. So we see that 2x is our LCD. So I'm going to multiply this whole side by 2x, and I'm going to multiply this whole side by 2x. So what we're basically going to have is the 2x's, because that's the least common denominator, is going to cancel out our denominators. Let's look at that. 2x times 4 over x is going to be 8x over x, plus 2x times 5 is 10x over 2. And that's going to equal negative 11 times 2x is negative 22x over x. Well, simplifying all of this, 8x over x is 8. 10x over 2 is going to be 5x equals negative 22x divided by x is negative 22. This is a much easier equation to solve. We're going to subtract 8 from both sides. We're going to be left with 5x equals negative 30 divided by 5, x equals negative 6. This is going to give us the one solution. It takes away that extraneous solution of 0, because as we can see, we still can't divide by 0. And you should check your solution, but since we already did that, we don't need to do it again. So again, multiply each term on both sides of the equation by the least common denominator of the terms. So looking at another example, we have 5x over x minus 2 equals 7 plus 10 over x minus 2. Remember, first of all, this is like 7 over 1. So you're looking at what is the least common denominator of all of these. And hopefully what you're saying is the least common denominator is x minus 2. So going back to what we said, to solve a rational equation, you're going to multiply each term on both sides of the equation by the LCD. So I'm going to be multiplying this side by x minus 2 and this side by x minus 2. Doing that, we have 5x divided by x minus 2 times x minus 2. These are going to cancel out, and we're going to be left with 5x equals 7 over 1 times x minus 2 is going to be 7 times x minus 2 all over 1. And then again, 10 divided by x minus 2, these x minus 2's are going to cancel out, and you're going to be left with 10. But remember, you're doing this to both. So even though I just crossed this off here, I did take that x minus 2 and apply it to the 7. So we're left with 5x equals 7x minus 14 plus 10. I'm going to subtract the 7x, and I'm left with negative 2x equals negative 14 plus 10 is negative 4. Divide by negative 2, and I have x equals 2. Well, what do we need to do now, as we need to do every time? Hopefully you're saying to yourself, check. Check for an extraneous solution. So 5x, 5 times 2 over 2 minus 2 equals 7 plus 10 over 2 minus 2. This is going to give us 10 over 0 equals 7 plus 10 over 0. Can we divide by 0? No. So x equals 2 is going to be extraneous, and the actual answer is going to be no solution. This is why it is so important to check for extraneous solutions, more so in this unit than when we were doing the log units, because this is the problem you're going to run into a lot, this division by zero that you have to be very careful of. I want you to try this problem on your own. Remember, you want to multiply each term on both sides of the equation by the LCD of the terms. So you're looking for the LCD of all of this. So pause the video now and try. Okay, so first of all, we know that x squared minus 1 is actually x plus 1 times x minus 1. And we know this plus 3 is actually over 1. So the LCD is going to be x plus 1 times x minus 1. Taking that into account, we're going to multiply both sides by the LCD. So I'm going to multiply this side by x plus 1 times x minus 1, and I'm going to multiply this whole thing by x plus 1 times x minus 1. Looking at that, we see that this x plus 1 is going to cancel out with this x plus 1. And this x plus 1 and x minus 1 are going to cancel out here. So we're going to be left with 4x plus 1 times x minus 1 equals, now with this 12 over x plus 1 times x minus 1, those are going to cancel out, so we're left with 12, and then 3 times x plus 1 times x minus 1. All right, multiplying this out, we have 4x squared minus 4x plus x minus 1 equals 12 plus, now we know x plus 1 times x minus 1 is x squared minus 1, so that's going to be 3x squared minus 3. If I went too fast for you there, the quicker way for me that I saw it was this x plus 1, x minus 1 was the factored form of this. And then I just took this 3 and multiplied it by each term here. Now let's simplify. 4x squared minus 3x minus 1 equals 3x squared, and then 12 minus 3 is plus 9. I'm going to bring everything over to the other side. So I'm going to subtract 3x squared, and I'm going to subtract 9. And I'm left with x squared minus 3x minus 10 equals 0. Well, the factored form of that is x minus 5 times x plus 2 equals 0, and I get x equals 5 and x equals negative 2. Hopefully you were at least able to get that far. It's just a matter of multiplying by the least common denominator and then simplifying correctly. We still have to check our solutions. So just to give me some more space and changing the page, there's our original equation. Let's start with x equals negative 2. So we have 4 times negative 2 plus 1 over negative 2 plus 1 equals 12 over negative 2 squared minus 1 plus 3. That's negative 8 plus 1 is negative 7 over negative 1 equals 12 over negative 2 squared is 4. 4 minus 1 is 3 plus 3. Negative 7 divided by negative 1 is 7 equals 12 divided by 3 is 4 plus 3, which equals 7. So we know that this works. X equals negative 2 is a solution. Now let's look at x equals 5. 4 times 5 plus 1 over 5 plus 1 equals 12 over 5 squared minus 1 plus 3. This gives us 4 times 5 is 20 plus 1 is 21 over 6 equals 12 over 5 squared is 25 minus 1 is 24 plus 3. 21/6, that simplifies to, if I divide it by 3, 7/3. And then I have 12 over 24, which is 1/2, plus 3. Oops, I just realized I made a huge mistake. This is 7/2. Sorry, I was dividing by 3. And then 3 plus 1/2 is 7/2. So this works as well. So I know that my final answers are going to be x equals -2 and x equals 5. But you have to check your answers. I cannot emphasize this enough. Here's one more problem for you to try on your own. My advice, because these are fractions without any addition or subtraction, you can go back to that original method of cross-multiplying. So you can use cross-multiplying to solve a simple rational equation for which each side of the equation is a single rational expression. I repeat, my advice would be if there is adding or subtracting, multiply by the LCD on both sides. But if there's only a fraction, a rational expression on each side, use cross-multiplication. So pause the video, try this problem on your own. Okay, so hopefully you got x squared minus x equals 2 times x minus 1. X squared minus x equals 2x minus 2. Subtracting 2x and adding 2, we get x squared minus 3x plus 2 equals 0. Factoring this, we get x minus 2 and x minus 1, and that means x equals 2 and x equals 1. If you got that far, nice job. You're halfway there, but you have to check. So we have 2 over 2 squared minus 2 equals 1 over 2 minus 1. 2 over 4 minus 2 is 2 equals 1 over 1. 1 equals 1. So we know 2 works. Now trying 1, we have 2 over 1 squared minus 1 equals 1 over 1 minus 1. That gives us 2 over 0 equals 1 over 0, and we can't do that. So 1 does not work. It is an extraneous solution, and our final answer is x equals 2. It is very important that you show me this. Even if you see right away that 1 minus 1 is 0, show me that you know 0 is in the denominator. You will not get full credit otherwise. So that's the end of our lesson. You have a Quizlet tomorrow on adding, subtracting, multiplying, and dividing rational expressions. No equations will be on it. And then we'll continue to work on this starting tomorrow.